Phoenix Jones. All you criminals should head for home. Phoenix Jones is it to save the day. Phoenix Jones, the Guardian of Seattle. Don't tase me, Joe. It's got a taser as well.
Hello, and we're coming to you from the lab. I'm Nathan Woollett.
I'm Sean Mitchell.
So this week, as promised, we'll talk about the blood moon.
Yes, we'll talk about it in great detail.
However, first, we've had some very interesting news come from the world of science. We've had this year's Nobel Prizes announced.
Ooh. Nobel Prize. So, Nath, what actually is the Nobel Prize?
Well, a Nobel Prize was actually part of the will of Alfred Nobel.
By the will, do you mean the will of him? Or do you mean his will of death?
Will of death. It was his will of death. So, Alfred Nobel was he was kind of a bit of a Renaissance man, but of the late 1800s.
You know what else? I've only just realised that's why it's called a will.
What?
You know, when they die, you have a will. It's the will of that. Doesn't matter. I just realised that's why it's called a will.
I don't get it.
Oh, it's because it's the will of that person. When they die, they want this to happen.
Oh, God.
Yeah.
Ah. Yeah, no, I just got that.
Yeah.
Yeah, no, I'd never realised that before.
Yeah.
Cool.
Crazy.
So Alfred Nobel, he wrote poetry and drama, spoke several languages, but is quite noted for his kind of progressive thoughts for the time, very interested in science and invention and entrepreneurship.
Oh, yeah.
And so when he died, he left part of his fortune to start up a prize series to award people for, progress in these areas.
Yeah, do you have like a massive how do you get a massive fortune?
I don't know, to be
He's just
honest.
like one of them people who's had a massive fortune line.
Yeah.
Like back in the day when you could do that.
Yeah, he said he's known as a technical genius, so I imagine he invented like a
money.
type of
He invented his own
something.
money. That's how he had so much.
This is Nathan from the future. Obviously, Alfred Nobel made his money from inventing dynamite. Now back on with the show. So he set up a prize, and there's a prize in physics, one in chemistry, one in medicine, one in literature. There's one in economic science, and of course, there's a very famous the Nobel Peace Prize.
For being the most peaceful.
I wonder if the Dalai Lama's ever won that.
Well, he's the most peaceful. Well, he's the most calmest, isn't he, as well?
Yeah, he's very calm, very peaceful.
Maybe he has. But they get it for actually doing something for peace, like actively being...
I guess that's probably what it more is.
Peace.
Yeah.
Whereas Dalai Lama is constantly at peace.
He's so peaceful.
He's so zen. Oh, man, he's so zen. So, the Science Prize.
Yes, the Physics Prize. So this year it was awarded to Takaaki Kajita and Arthur MacDonald.
Right, and who were
for
they?
the discovery of the neutrino, what's referred to as flavor oscillation. Well, we'll get into that in a minute.
Okay.
But basically, these are two guys who were simultaneously working on similar experiments back in like the 1960s.
They started in the 60s, really?
Nobel Prizes are like, you generally get them towards the end of your career for things you did at the start of your career.
Oh, cool. I assumed it might be a while, but I thought it might be like, 2002 or something.
But yeah, they were both working on neutrino experiments. So neutrinos are these very, very light particles. At the time, they were actually thought to be massless. And they come in three varieties. So in a later episode, we'll talk a bit more about particle physics. But at the moment, all you need to know is they come in three different varieties.
Salt and vinegar.
Yes.
Cheese and onion. Yeah.
And jalapeno, because, we like them spicy.
Well, the flavour particles.
So Arthur MacDonald was working at the Sudbury mine, where he made one of the first neutrino detectors.
What, like for fun? Or just kind of made it by accident? He planned to?
He planned to.
Okay, cool.
Right, I'll read out some of the stats for this, because it's ridiculous. So they had a cylindrical tank, which was 20 foot in diameter and 48 feet long. So it contains 500,000 litres of tetrachloroethylene. And I did not have to read that off the internet. Which is basically the same fluid as they use in dry cleaners.
Okay.
What happens is when one of these neutrinos comes through the tetrachloroethylene, it can interact with part of the particle and it makes a little flash of light.
Oh, okay.
And then by examining the way the light looks, you can actually work out what flavour it was. So it's kind of like seeing the packet of crisps
Yeah.
and being able to tell what flavour it is by the colour.
Okay.
To really know, you have to taste them. But by looking at the colour, you get a good idea of what the flavour will be.
Sometimes you get like Walker's being green for salt and vinegar, and then you go to McCoy's, and then it's got green for cheese and onion.
Well,
you don't want that.
Most other crisps are blue for salt and vinegar, right? So
Yeah, exactly.
you get a good idea. You're not 100%. But yeah, so these guys were looking at neutrinos that were coming from the sun. Because we kind of know, we have a good idea of what's happening in the sun. We know what mixture of flavours we should be getting.
Yeah.
Interestingly, they found a different distribution of flavours than what they were expecting.
It was like a mixed bag. It was great.
Either what we think we understood about going on in the sun was wrong, or something was wrong with their experiment. Now, fortunately, at the same time, over in Japan, Takaki Kajita was working on his heavy water detector.
Right.
So he was looking for the same particles, but rather than looking for them coming from the sun, he was looking for them coming from the upper atmosphere. So every now and then, we have these things called cosmic rays that come down.
Cosmic rays.
Cosmic rays. They're basically just high energy protons, which can come from the sun, but they can come from other sources.
Okay.
But when they hit the upper atmosphere, they interact with it, and you end up producing a muon, a heavy partner of the electron, but they also produce a muon neutrino. So he was hoping to detect these muon neutrinos.
Right, okay.
However, when he was looking at what he was getting, he found that he actually had a mixture of muon neutrinos and other types. So again, it's like going to the bar and asking for, I'll have a pack of salt and vinegar, please. And then you get it, and you've got like this weird blended pack of all different flavours.
Probably be the ultimate packet of crisps, really, though.
It would be pretty good, to be honest. And it turned out to be pretty good for these guys.
Oh,
because
sweet.
it solved one of the mysteries about the mass of the neutrino.
Oh, right.
So for them to be able to change their type, they actually have to have a small mass. Now, they are very small masses, but it means that they've definitely got one.
Rather than not having one.
Rather than not having one, which we thought was the case originally. And that's essentially what these guys have got the Nobel Prize for.
Well, that's pretty cool.
It's kind of cool,
Well
right?
done, science.
So let's go on to our main topic for the show, the blood moon.
Moon full of blood.
So yeah, we had the super blood moon, which is a coincidence between a blood moon and a supermoon, which are two individual things. So the super blood moon's really rare because you have to have both things happen at the same time.
Okay. That's cool. Okay.
Yeah, we'll go through both of them separately, and then we'll go through why it's rare that they happen together.
Well, it's called a super blood moon, so let's go with the super first. Why is it a super moon?
So the supermoon refers to how big it is in the sky. So when we think about, we're going to have to think about orbits here.
Right, okay. Is supermoon, that's a full moon that's every month, right? But a supermoon, I guess, is when it's bigger.
Exactly.
Wears a cape.
It looks bigger in the sky, so it kind of got the nickname a supermoon.
Okay, cool. So why is it bigger in the sky, Nath?
Well, why do you think, Dad?
Well, as I interrupted you when you were saying something about orbits, I'm going to assume it's when the moon is orbiting around the Earth.
So, obviously we have orbits around the planet that the moon takes, and they are pretty much circular, but they're not quite. So you actually have an elliptical orbit. So if you think about an ellipse, it's like a rugby ball kind of shape.
Oh, okay, cool.
When it's at the farthest ends, it's actually further away. When it's in the middle, it's actually a bit closer. Okay, so supermoon is the coincidence between the full moon or a new moon and the closest approach of the moon to the Earth.
Okay, that's cool.
That's quite cool. Would
that pass on a test, do you reckon?
Yeah, I don't think people get quizzed on this.
Oh, did they not?
No, I don't think
so.
What
are we doing this
for? It's kind of cool to know. It's cool to know, and you have to talk about orbits and stuff.
It is cool to know.
So it's when the moon's at the closest part of its orbit, as well as being a new moon.
Yeah.
So it's a full moon. However, you get different degrees of supermoon.
What?
Yeah, I know. This is where we get a bit complicated.
What?
So the orbit of the moon is not just around the Earth. It's also affected by the sun. So, in the solar system, the sun has a lot of mass. So it can't just be ignored.
It's got a lot of mass. It's all about the mass.
It has so much mass.
Big old mass.
So at all times, the sun's kind of pulling on the moon a bit, which means that the orbit of the moon kind of wobbles around the Earth a little bit. That's why the moon's not always in the same position every night. It wobbles up and down and back and forth.
Okay, cool. That makes sense. I've never really paid that much attention. I assumed it was in the same position, to be honest.
Yeah, you do.
I don't ever really look that much at the moon.
But
I will now though, every
yeah,
night and
just look at
day.
it.
I'm gonna look for it.
You can see it in the day sometimes.
Sometimes I can. I've got a keen eye.
So you get different degrees of a supermoon. So sometimes it's closer than others. To have the closest approach to the moon, what you actually want is all three bodies to be in a straight line. So as the moon is coming around the back of the Earth, the sun's actually pulling it closer.
Right. Okay.
So you end up with all three bodies being in a line. You end up with them being compressed a little bit, and this is how you get the super moon.
Hold on.
Which
Isn't
is
that
what we
like
had a couple of weeks ago.
Isn't it like an eclipse?
Well, yeah, this is why it's a super blood moon, because the eclipse causes.
Oh, am I jumping the gun?
You are.
Oh, okay. Go on.
Cool. So I think that kind of explains the
super bit. Should I try and
the
cap
super bit of the supermoon.
from what I've learned from just now?
Yeah.
Which is the moon orbits around like a rugby ball.
Yeah.
Okay. And to get the super, you have to be in the middle, basically, of the rugby ball. And the sun also has to do something and pulling it a certain way.
Yeah. So the reason that the moon looks red is because of the same reason that the sky looks blue.
That makes no sense because then the moon will be blue.
Well,
it's because the water's reflecting into the sun, right? The sun, the moon.
Yeah, it's the blue water reflecting into the moon that makes it red.
Yeah.
No,
cool.
so the sky's blue because of an effect called Rayleigh scattering. So this is where light is passing through the air, and depending on the wavelength of that light, so the colour of it, it gets its trajectory bent by a different amount.
Yeah.
So red light travels in fairly straight lines, but blue light gets scattered quite a lot more.
Okay, so when the sun's setting, it's less dense. It's not there or something like.
So when the sun's setting, the light's travelling through more of the atmosphere.
That's right, more.
Yeah, so more of the blue light's getting scattered away. And this is why it looks red, because when you remove blue light from white light, you end up with the red end of the spectrum. So this light is exactly what's causing the moon to look red. It's basically just passing through the limits of the atmosphere, getting the blue light removed from it, making our sky look blue, and then shining on the moon, making it look red.
Ah.
Or blood red.
Full of all the vampires.
Actually, I just realised that this will probably come out quite near Halloween, so...
Worth it.
Worth it. Sold.
It's a super blood moon because, it's got superpowers. It's bigger, isn't it? That's it.
It's bigger and red and makes people want to kill each other.
Actually, that's amazing. I watched a movie last night. It's like a documentary movie. It's what's it called? What We Do in the Shadows.
Yeah.
It's got Jermaine Clement in it. It's like co-wrote and directed by him, and it's hilarious. It's so funny. It's about like a group of like vampires, but the kind of old school vampires, and it's them dealing with like life now. But anyway, What We Do in the Shadows. Recommend it.